you. I'm excited to be here. So, especially at the first ever meeting of this kind, this regional meeting. So, thank you for putting this on. Let's see if everybody can hear me. All right. So, as Brad mentioned, I'm an anaplastologist, and so something that I'm very passionate about is the face, because I'm making facial prosthetics. And so I wanted to take the face and break it down into proportions to help with individuals that are maybe sculpting the face or drawing the face, and think about the face in 3D as I do as an anaplastologist, because with the advent of ZBrush and more cinema work, we're going to be sculpting the face and making customized images for our own works. And you get a couple of good faces in ZBrush and you can look at them in any angle, but you've got to get those angles right. So I'm hoping that this talk will address some of the questions that you may have, and maybe address what you were taught in art school. So Brad's passing out some paper. What I'd like you to do really quickly is think back to what you were taught in art school as far as facial proportion, and draw some lines about where you think the eyes should be, the bottom of the nose should be, the lips should be, and let's do a test, because I'm going to compare what we were taught in art school against anthropomorphic data, so the actual data that's found in recent studies for comparing populations. So hopefully you have a pen. If you don't have a pen, maybe you can draw on your eye device if you don't have an actual writing implement. Think about the width of the eyes, the width of the nose. What are the landmarks you would be concerned with? And this is about 1-to-1, so what you have on the paper. So if you need to cheat, you can do that. Okay, 30 more seconds. You don't have to draw on the eyes or the specifics, but think about the landmarks. Where are you crossing over? All right. Okay, time's up. So, tell me a couple of the main landmarks that you think of. Nose, what proportion would the nose be to the rest of the face, maybe? Is that something you think about? Yes?
Generally, we're speaking about the whole head, the eyes generally fall halfway.
Yes, that's a good landmark, or something we were taught in school, so halfway. The nose is in thirds, so think of it, so these are some landmarks that were studied. So take the nose, and the nose is equal thirds, so that's a canon that was used by Da Vinci and Behr. So that was one of those canons developed in the Renaissance times. And what I looked at was actually what the data says. So an average of North American, Caucasian, and blacks, and how that larger population averages out, and how that compares to what we were taught in school. So those things could be forehead height equals nose length equals lower face height. So is that correct according to the data or not? Nose length to ear length, is that a correct, valid measure? So what I'd like to do is take you through all of these canons or Renaissance ideals and evaluate that against actual data and give you some values to look for and some resources that you can research on your own. So this is the 3-section facial profile canon. So the nose is broken into 3 equal, the nose, using the measure of the nose, the face is broken into 3 equal parts. And you'll see the image on the left is equal parts, but the image on the right shows you what the data shows. So this is based on data by L.G. Farkas. He started doing these studies in 1985, or started publishing them in 1985. There's the most recent one is 2007, where he's comparing North American blacks and whites. And so you'll see here, it's not exactly accurate. That 3 equal part canon is not exactly accurate. And it's actually not accurate in any percentage of whites or any percentage of blacks. And more often, the lower face is larger than the nose value. So if you're trying to kind of eyeball and make a face up on your own, think about having that lower third just a little bit larger than the other 2 areas. So let's see what this looks like in practice. So here's the nose and the face. You'll see on the left, it's the canon, and on the right, it's the database revision. So based on these studies, we have a value of 51 millimeters, and this is for a female Caucasian head. So I'm going to use the female Caucasian as our model. The papers have male, female, black, and white as data points, so you can go back and reference if you want another characteristic. But I will talk about a female African-American model as well. So the database revision, you can see already the height of the nose is different. So the nose is longer. And on average, only 4.9% of whites in America follow this canon, and 0% of blacks do. And on average, the nose is larger than the third of the face, as we mentioned before. So the nose width. So one of the canons that was used, and we were probably taught in school, is the nose width is equal to 1/4 of the face. And according to their 2007, the Farkas data, whenever he compared the African American and white populations, this actually does average out. And I'm talking about the zygomatic arches, and so not the whole width of the face, but the zygomatic arches. In general, this is a pretty valid measure. When it's not valid, and the nose is slightly larger than that 1/4. So if you find variations, it's going to be that the nose is slightly larger. So we got one good from art school so far. So the orbital nasal canon. So the width of the nose is equal to the intercanthal distance is equal to the fissure of the eye. That's generally accurate in about 40% of whites, only 3% of blacks. Whenever it's not accurate, you'll find that the nose is actually larger than the intercanthal distance or larger than the eye fissure. And I put the values in. The average data for females in North America, intercanthal distance was 31.8 versus an eye fissure of 30.7, and the nose width of 31.4. So you can see how that data measures out. All right, mouth width to nose width. So you probably heard your mouth is 1.5 times your nose. We find that that's only true in about 20% of whites and 1% of blacks. And the variation is whenever it's not correct or not accurate to an individual, generally the mouth is larger than that 1.5. So the image on the left shows that 1.5 of the nose width, and the image on the right shows the actual data measurement, which is 50 millimeters, which is larger than that 1.5 of 31.4. Okay, so the lower thirds canon. So Durer went forward and broke the one of his canons of the thirds of the face down into the lower half of the face, being equal parts as well. And in younger individuals, this data works out. So earlier studies by Farkas around 1985, whenever he studied 6-year-old to 18-year-olds, that generally works with the data they found. But when you look at 20-year-olds to 25-year-olds, which that 2007 study shows, it's not accurate. And so the lower third of the lower third is actually a little bit larger. So the ear to nose canon, so your nose length is equal to your ear length. If anyone's seen an older gentleman, you'll know that's really not true. But even looking at 20-year-olds, 20 to 25-year-olds, Generally, the ear is larger than the nose. And, you know, I was always taught to line the ear up with the top of the brow and the bottom of the nose, and that's just not quite accurate. So the ear is actually 60.4 millimeters, according to the data, versus a nose of 51 millimeters. That's a pretty big difference. I don't know if they measured on a cant or straight up and down. That would be something I'd want to investigate further. But that's a pretty big difference. It's only valid in about 4% or 5% of whites and 1% of blacks. So this shows you all the canons together, and the data sources that I looked up, generally referring to Farkas, but other individuals did these studies based off of his research. So they studied Asian populations, they studied African populations in the continent of Africa. So there's a lot of studies on facial demographics that refer back to the original data. And you know, I'm going to email Brad a PDF with my reference list, so you guys will have it. But this is the Canon measurements without all the lines, so you can see. I just feel more comfortable looking at the one on the right. The one on the left is, you know, accurate. There's so much anatomical variation, but the one on the right just feels more balanced to me, having that lower third just a little bit larger. So another canon, whenever you're thinking about looking at a profile view, something that we were taught in school is that the nose tilt is equal to the ear tilt. That's just not accurate. That's a way larger measure. What I do as an anaplastologist is I actually mark where the jaw line is, the angle of the mandible. The angle of the mandible is your best measure to get your ear tilt. So if you can kind of visually think about the angle of the mandible on the drawing you're doing or the 3D sculpture you're doing, that's how you can tilt the ear. And that's a pretty accurate measure. And then lower face angle is something to consider. So if you have a jaw that's projected too far forward, you can have that prognathic look to it. So according to the data from 2007, there's actually a 13-degree tilt from the plane back in space. So the jawline goes back a little bit. So that's something to think about as you're drawing. And when you're taking reference photos, so looking at a reference photo, a lot of times these models on iStock photo will really push out their neck. So they look, you know, very svelte. And that's just not great for what we're doing. It's not necessarily accurate. So that it'll have an abnormal appearance whenever you break that down into an illustration or even a model. So consider that. So let's look at a Caucasian female versus an African American female. This is, generally speaking, there's a broader nasal width, there's a broader eye fissure, there's a broader intercanthal distance, and this is the measurement according to Farkas. So 32.4 versus 30.7, 34.4. We can also talk about feminine versus masculine features. And so this gets more into the art school training and characteristics that you observe visually, but you just may not think about it. For males, you've got a broader brow, brow bone. The eyebrow is a little flatter and not as arched in a male. The nasal angle is greater. So generally speaking, males have larger noses. They're larger individuals. The height of the face is going to be larger when you look at the data. The angle of the nose is more of a 90-degree angle, so the tip is more of a 90-degree angle, versus in females it's about 110 degrees or 100 degrees, so it's a sharper angle in a female, or a greater angle rather. And the philtrum is more straight up and down in men versus women. And of course the lips are a little bit thinner, the jaw is a little bit broader, and you can see an Adam's apple. So those are your male versus female characteristics. And this just shows the greater angle. So men are about 90 to 95 degrees, women are 105 to 110 degrees, thereabouts. So photographic reference. So I mentioned, you know, getting references from iStock Photo. I hear giggling from my students. One of my students was kind enough to volunteer to be my model. So think about if you're taking photograph reference of yourself, what are the pitfalls you can run into, especially if you're really going to just, speed up and trace that. You got to be careful and think about your facial proportions. So the image on the left would be more of a straight, flat image, a straight-on image. You've got an image from above, and that really changes the proportion of that lower third and makes it smaller. An image from below, slightly below, makes the lower third even greater, so that's going to mess up your proportions. And then the ubiquitous iPhone selfie. That's the too close image. Our students often wonder why we know or how we know that they took a photo with their iPhone. And this is why, students, this distortion. So just be careful. If you are going to take photographs with iPhones or devices with very small photo chips, you have to take them from far away and crop in. Otherwise, you're going to get this wide-angle distortion. So let's talk about eyes for a little bit. We're going to talk about individual features now. So generally speaking, unless age has been involved, the lateral canthus is going to be higher than the medial canthus. And then it's also important to note, especially for our 3D modelers out there, the depth. So the medial canthus is farther forward and the lateral canthus is farther back. And that's something I think beginner modelers maybe don't appreciate, don't really push those angles and really think of the face as a form, because we're so used to looking at it in a 2D plane. So again, this is looking at the form. The lower lid is more proximal, the upper lid it projects out farther. And then this is showing one of the pitfalls that you may find, and one of the most common mistakes that I see in beginner illustrators is the lids really need to sit on the eyeball. You shouldn't see white above or below, because that's a sign of a pathology, so ptotic eyelids. You can have ptotic eyelids where it's too low, or you can have you can have lid flare where it's too high. So be careful of the references you're looking at and be aware of having those lids really sit on the iris itself and not have white space above or below. And the nose, generally speaking, the columella is going to be lower than the nostrils. So this is something that we often miss, this lovely junction here. This is something that I often sculpt back into facial prosthetics. We can sometimes really cut this short and have a really sharp angle right here. So be careful of that. And the base of the nose, especially for the modelers. You're going to be looking at it at all angles. Take some attention to the nose. Of course, I'm a little partial because I love noses, but take a little attention to the nose, and you can break a nose up into halves, and the top half is the tip of the nose, and the bottom half contains the nostrils. And then the columella makes this lovely triangle. A lot of that shape, though, is inside the nostrils. Whenever you're looking at it from other angles, you really don't appreciate the broadness of that base because it's going backwards in space. And when it's lit from the front like this, it shows up as a triangle, but you really shouldn't see that from, let's say, this 3/4 angle. See how the columella actually is deep in here? That broad triangle base goes in there. Okay. Ear anatomy. So I think ears are the redheaded stepchild of facial anatomy. They're sometimes superfluous, or so people think, until they have me look at their work. And I just encourage you to know the ear anatomy and try to imagine the depth of the concha. And whenever you're looking at reference photos, sometimes you can't appreciate the 3D nature of an ear. And it sometimes gets flattened out, and you get weird angles or weird interpretations of the ear from different angles. So consider how deep this is, and how deep this can be, and this soft, rounded curve. So lips are another feature that has some nuance to them. So we've got the simple outline on the left, and I created this contour image to show you how the volume of the lip actually can taper down and create a shadow, how the volume of the lip actually ends before the vermilion, the color of the lip. And so to create that realistic shape consider adding a little bit of shadow so that the lip actually curves and folds into the face before the vermilion or the color ends. The same thing happens up top as well. And the top lip, and there's a lot of variability with lips, especially because they're mobile, but the top lip generally has 3 volume-based areas, 3 pillows or so, and the lower lip is made up of 2 soft volumes. Something to consider as well, this generally goes for facial anatomy, especially whenever you're trying to create an illustration and not create a distraction, is facial symmetry. A study done looked at the perceptions of individuals looking at lip cant, so where the corner of the mouth actually goes lower, and about 87% of individuals can perceive the difference within a 4-degree difference. So this right here is a 4-degree difference. They perceive that difference, and 17% of those individuals find it aesthetically unacceptable. So I just encourage you to think about implied messages. So does this individual have a nerve disorder that I need to worry about? So it's really easy these days to mirror an image to create that symmetry. And that goes for all areas of the face. Okay, how are we doing on time? I think we're doing pretty good.